Hello, everyone. Welcome back to another assessment preparation video. There's a lot of the stuff that we're going to be able to do in the calculator today, but teacher's going to want you to show your work by hand if you can. So just be careful about just giving answers and not showing any work. So first formula that we're going to be using here to calculate simple interest is that I is equal to PRT. We're going to be using that in several of these initial problems. So to find the total amount that we're going to have, if it's a simple interest problem, you're going to have your principal plus your interest. So another way to write that is P times 1 plus RT, like that. Okay, so your total amount, or this is your balance, something like that. I'm going to let you guys do most of this that is calculator work in your calculator. I'll just show you how to use your calculator to do this. I'm just going to be able to type in 14,000 times 2% times 1 year, and you get your answer of $280. So you're going to add that then to the original $14,000, and you're going to get a balance of $14,280. It's not hard, just pay attention to fact that these are all annual interest rates. We're going to call that APR in some of these later exercises. So I'm just going to go ahead and fill these in for you because I don't think that you really need me to type calculator buttons for you. If you have questions specifically about any of these, you can't get the answers that are on the answer key or that I'm writing down, because I'm writing down the answers that are from the answer key. Just go ahead and make an appointment with a Math Central tutor, or ask me in one of the help sessions. All right, so let's go ahead and let's look at, we've got different situations going on here, compounded, compounded annually, and then round to the nearest cent. Okay, so that's going to be important. Pay attention when you're rounding to the nearest dollar, to the nearest cent here. So simple interest here, for this one that we want to find first, the simple interest is going to be 810 times 4% times 17 years. Simple interest is going to be $550.80. So that's going to be I, my simple interest, 550.80. When I find my amount, that is the principal plus the interest. When I use this other formula up here, I'm going to take the principal times 1 plus R times T. Sorry, that's not it. Compound interest formula. 1 plus R over N to the NT. So how many times is it compounding? It's only compounding once a year, to the NT. Let me write that down here. This compound interest formula, P times 1 plus R over N to the N. They use Y, and they use APR here. So APR for R, and they call the time capital Y for years. So I'm going to take this APR. N here is once. They're saying it compounds annually, so N equals 1, my problem. So to the 17th power, I'm going to subtract my original principal to find out how much interest. Here, I'm going to round this to the nearest cent. It's going to be 1577.80. So that means that I'm going to call this my simple interest. I'm going to call this my compound interest. Just going to put a little C there, is going to be number minus the original principal of 810 is going to be a compound interest of 767.80. And we have a difference here of $217. That's not the only thing that they're looking for, but that's the last thing. So I'll just go ahead and put that on the blank. So simple interest, total balance. Subtract the principal out of the total balance to get your compound interest and find the difference between the compound interest minus the simple interest to get the difference rounded to the nearest cent. All right, let's do that again with this one. It's just bigger numbers. So we're going to get that my simple interest here was $2,334 and I think that's 16 cents. Let me just verify. 68.65 times 2% times 17 years, 10 cents. Okay, 10. There we go. My amount is going to be 68.65 times 1 plus my R. So that's going to be 1.02 raised to the 17th power. It's going to be an A of 9612.66. Going to subtract out my principal from that to get what my interest was. It means I had a compound interest of 27.4766. And then I'm going to subtract out my simple interest from that to find the difference. And my difference here is going to be to the nearest cent, $413.56. All right. Next set of problems, use the compound interest formula that we just talked about up here. This compound interest formula, I'm actually going to write that out up here as it's probably the more important one to know because it's just going to come out correctly, even if it's only 1 year for the amount here. Compound interest formula says A equals P times 1 plus R over N to the N Y. I'm using the Y instead of T for the number of years. So this is going to be my P. This is going to be my we're going to call this APR. It's going to be my APR. We're going to think of that as 0.02. This is going to be my Y for years, right? So we're going to just plug that into the calculator. It's going to be 20,000. Times 1 plus 0.02 divided by 2, because it's for 2 years, right? Oh, I'm sorry, not right. Number of payments per year is still 1. It is, yep, to the n t, so 1 times 2, that's 2. There we go. Got 2 compounding periods here. And this should be a total of $20,808 when we're done. This is, you can just keep going here. Same thing. This is going to be 8,000, 1.031 to the 5. And that's going to be 9,319.30, round to the nearest cent. You just check, make sure. Yes, we are going to the nearest cent on these problems. 10,000. And this is 0.024 to the 18th. This is going to give us 15,324.96. And then this is going to be 310 times, sorry, this is not a 0, this is a 1. 1.033 to the 12. And this is going to be 457.68. Okay, so again, 1 plus your interest rate is just going to be tack the interest rate on to the end as a decimal behind the 1. If you're not having any changes in it being calculated multiple times a year, that's how it's going to work. As soon as you get into the next set of problems, though, all of these things here, it says it's compounded annually. That means n is going to be equal to 1. See, now notice this is semi-annually, which means n equals 2. Quarterly means n equals 4. Semi-annually, n equals 2. Monthly means n equals 12. So my n's are changing in this formula, both in the APR over n part and in the NY part. We're going to have to account for both of them. So let me just show you, do this by hand, but let me just show you that in this part, there's a fun little tool on your calculator. As long as you have a TI-84, I think, I don't think you have to have an 84 plus. This is a free app that you can use. It should be on everybody's calculator, called Finance. I'm going to come in here to the TMV solver. I'm just going to show you that I have, so 2 cycles a year times 5 years means that I'm going to have a total of 10 payments. That's what the capital N is there. My interest rate is 2%. Don't write it as a decimal. It says right there that it's a percent. Go ahead and write it as a percent. Present value right here, it's my P, that's my principal, $19,000. Don't worry about payment. It's not what we're interested in. We're going to want to find future value in a second. And that we have 12 cycles, 12 payments a year, 12 interest cycles a year. Keep that on end. Don't worry about it. Put your cursor over where it says FV, which is the future value of the investment. Hit your green, for me it's green, hit your alpha key, and then hit enter, which is solve. And don't worry about that negative sign. It just has to do with a banking thing because this is money that's coming in from you. This is money that the bank is going to have to pay out in the end. So it has a negative sign because it's a money going out of the bank. And so compounded semi-annually. So R over N let's see, to the, right, this is semi-annually. So this is 2. There we go. And that is right there. Make sure you change that because that's where that number comes into account. How many cycles there are a year. That was semi-annually. So there's my answer right there of $20,987.82. Now you can and should show your teacher all your work. You should use the formula that says that A is equal to P times 1 plus R over N to the N times Y, right? Like that. And you should do all that in your calculator. You should be able to simplify it step by step. Let's just show you that we get the same answer. 19,000 times 1 plus R over N to the N times Y, and we get that answer. So go ahead and I'll just write down what the setup is for all these problems. 12,000, or I'm sorry, 1,200 times 1 plus 0.04 over 4 to the 4 times 2. This is 8430. 1 plus 0.04 over 2 to the 2 times 8. This is A equals 5,500 times 1 plus 0.04 over 12 to the 12 times 6. And this is A is going to be 3,000. 1 plus 0.03 over 12 to the 12 times 6. Just going to write these answers in. Go ahead and do all the work to show these. There's just not enough space here for me to do that. Do those on your own paper. 1299.43. Again, you can use your calculator like I showed you to check your work when you're done, if you have that app on your calculator. So that might be helpful to you. And this one is 3,590.85, and I'm just going to check all my answers on the answer key to make sure I didn't make a silly handwriting mistake. 20,987.82, 12,099.43, or 1,299.43. 11,572.58, 6,989.08, and number 16 is 3,590.85. That's right. Moving right along. Go ahead and erase this line. 17 is another one of these. I'll just do the setup here real quick. But this is going to be my A is going to be 7,001 plus 0.04 over, and this is daily, so that's going to be 365 days in a year to the 365 times 5. That is a ridiculous, amount of compounding there. Sounds like a payday loan to me, where they make you pay every day a little bit more interest if you don't pay them back right away. That's why I tell people don't get involved in those, because you are going to really, really pay for it. Oops. And just look at how much interest you would have to pay if this was a loan. If you borrowed $7,000, you're going to have to pay back $8,549.73. So, okay, the bank offers an APR of 1.75 compounded semi-annually. Find the APY. So the APY here, let me just write it up here, APY is equal to, I know this is a crazy formula, it is big parentheses 1 plus APR divided by N raised to the NY minus 1, close parenthesis for that, times 100%. I'm going to just do an example here, show you that's going to be open parentheses, 1 plus my APR is a decimal, 0.0175 divided by N. This is semi-annually, so that's 2 raised to the NY, so raised to the 2, and I'm just assuming 1 year here. So, and that's going to be minus 1, and then times 100 to change it to a percent. And this is going to be 1.76%. We're going to round it to the nearest hundredth of a percent. So it's going to be 1 plus 0.0175 divided by 2 to the 2 minus 1 times 100%. Okay. I think you guys can probably follow along similarly with those and get these numbers. If you can't, go ahead and ask me. Again, pay attention to the compounding periods. This is quarterly, so this is N equals 4. Semi-annually was N equals 2. This is daily, N equals 365. Monthly is N equals 12. Okay. Suppose that you start a savings account for $20,000 down payment that you plan to make on a house in 10 years. Okay, this would be in all these situations where you're going to be doing this problem solving, as much as you can in real life, you would use Excel or you would use your calculator with a TMV solver or TVM solver. Time value money is what TVM stands for. So how much would you need to deposit now to reach your goal in 10 years? So we're solving for P, for your present value, right? If you want the future value to be 20,000, this is your future value, and no deposits, so PMT is equal to 0. That's what they're saying. You're not making any monthly payments. APR is 3%. So it's just come in here. Again, you can do this all by hand, but let's look at, you want 10 years, and it's going to be NT. So this interest is paid out quarterly. So 4 times 10 is going to be 40. Interest rate is going to be 3%. Present value is the, I don't know, I'm going to put a 0 there for right now. Not making any payments. Future value, we want to be a payout of $20,000. So compounded quarterly. So 4 and 4. And present value, alpha, solve, and we get 14,832.96, right? And again, I don't know how much you're going to be allowed to use the calculator. It's going to tell you in real life, going to be able to use the calculator. If you have to, you can use algebra 2 to rearrange this formula up here. For instance, since I was solving for P, P would have been A over 1 plus APR over N to the NY, like that. And your teacher may want to see this step where you solve the formula and put the numbers in and stuck it into the calculator. So can't tell you enough. Show your work, especially if you want to have the possibility of getting partial credit. Just go ahead and answer these questions, though. Again, just come on back and see me if you have specific questions about any of these, because I'm going to assume right now that you're going to be allowed to use your calculator until I hear differently. So assuming that you're allowed to just punch things into your calculator here, then I'm going to go ahead and give you these answers. And all of these were kind of the same thing that I just showed you. Okay, so all of those between 22 and 25 are all the same kind of problem. We're asking how much do you have to invest in the account now to have a certain amount that you want later. Now it's going to ask about, you do make the investment and somebody else makes a different investment. We want to compare and we want to see who has the better deal in 10 years and in 20 years. So let's just make a little table here. 10 years, 20 years, Andy and Carrie. Let's do Carrie first because Carrie's mentioned first in the problem. Carrie and Andy, right? So Carrie, after 10 years, has $1,062.75. And Andy, after 10 years, has $1,323.44. So Andy has more after 10 years. And in 20 years, Carrie has 15, 28, 34, and in 20 years, Andy has 2,370.07 cents. So in both cases, Andy has more in 10 years and 20 years. Okay. And then the next question says to find the APY given these different situations. So APY, if it is compounded quarterly, is going to be 6.14%. APY when compounded, nope, wrong line. (6.14%) and compounded monthly is going to be 6.17%, and when compounded daily is going to be 6.18%. It didn't have a big change on the yield to compound monthly to daily, right? Suppose that you want to have this retirement account in 40 years. How much do you need to deposit now? And they give you several different situations here. If it's going to be compounded daily, assume that no additional deposits are made into the account. So this is actually like that last set of problems that we did. Again, you can use your calculator to check your work here, but you're going to be solving for P equals A divided by 1 plus APR over N to the NY, and this is going to be 12,954.17. So, you know, it's really good. You could, if you could find this kind of account, which you won't find, that it's going to be compounded daily, but if you could deposit about $13,000 and, you know, in 40 years, you could have $95,706 for retirement. Okay. 29 asked me for the amount of time. We're solving for Y is our unknown here. To determine when to the nearest year values of the two investments will be the same. Well, this is like the problem that I did before with the two lines that intersect type thing. I can put the two formulas into my calculator and see their point of intersection. So I did that, and I found that Y was about 45.668, which means that it's approximately 46 years. You just are going to put in the formulas here for and Y1 for your first situation here, and then put in the, here, I'll show you. So this one is going to be P times 1 plus APR is 7% over N. This is compounded monthly to the N times X. X's are unknown. And then on this one, we have 7713 times 1 plus 0.04. This is compounded annually. So to the 1 times x, we're going to, you're not expected to know how to graph these by hand. We're going to zoom 0. See if we can get the point of intersection here. And we don't see it. So we're going to zoom out, zoom out. Still don't see it, so we're going to zoom out again. There we go. See how they just crossed each other over there? Second calc number 5. And this curve, that curve, and the point of intersection is, it's looking for it, is up there. Like I said, 45.668. So I approximated it 46 years. So you're going to have to use your calculator for some of these things, especially with graphing here. The average cost of a 4-year college education is projected to be $140,000 in 15 years. How much money should be invested now at 7%, compounded quarterly to provide this? So again, this is a P equals A over 1 plus APR over N to the NY situation. And we've got our A here. This is our A. This is our Y. This is going to be our N is 4, right? So we're going to be solving for P here. This is our APR. We didn't recognize that since that's the percentage. And this is going to give us that we need to put in $49,438.24. Now, you're using regular rounding rules in all of these situations, but just for instance, in this problem, I'm going to show you that you wouldn't want to round down in real life because you want to make sure you have at least $140,000 when you're done. You wouldn't really want to round down. So this is going to be 140,000 divided by, open parentheses, and I'm just going to do this just to be sure, 1 plus the APR 0.07 divided by quarterly 4 raised to the 4 times 15. Close my parentheses for my denominator. And okay, well, I rounded up there. But if this number was a 4, let's say, then would I really only want to put in, up to 23 cents? No, because then I would have less than the $140,000 that I would want. I would always want to round up in that kind of a situation, right? So just, again, you're using regular rounding rules here because that's what the book tells you to do, but you need to think critically in real life. You need to use quantitative reasoning and say, if I need to get at least that much money, then I need to put in this much money or more to ensure that I get that much out. So rounding down is not going to work for you in these types of situations in real life. I want to make sure you understand that. Okay, got one last problem here. Anna deposits $2,500 in a savings account that compounds interest annually at an APR of 6%. Dave deposits $2,600 in a savings account that compounds interest daily, an APR of 5.6. After 10 years, who will have more in their savings account? So I'm just going to make a table here. Anna, and Dave, since I have plenty of space on this page. My P here for Anna is $2,500. My P for Dave is $2,600. My N for Anna is 1. My N for Dave is 365. My APR for Anna is going to be 0.06. My APR for Dave is going to be 5.6%. So there it is. For both of them, the number of years, capital Y, is going to be 10. And so I can make the calculation here with the formula that A is equal to P times 1 plus APR over N to the NY, and come up with a calculation here that A is equal to 4477.12 for 10 years here, and A is equal to 4551.55 for Dave. So Dave has $74.43 more than Anna in 10 years, right? So there we go. That's everything for 4B. And we'll move on to 4C next time. 4C doesn't have as many problems, but they are a little bit more complicated and interesting. So I'll show you more work on those problems. I just have a feeling with 4B that you guys have done this financial math a little bit somewhere in high school. This is probably not the first time that you've seen this, even if we also do these problems in developmental math when we talk about exponents. So wherever you took anything where you had an introduction to exponents, you probably talked about compound interest as one of the examples of where you were going to use exponents in real life. You probably did some compound interest problems somewhere. So if you have not, that's okay. See your MDE teacher if you are taking MDE, see Math Central, tutors, make an appointment to see your professor during his or her office hours. As we may be, using these videos for other professors later, not just the one that I'm making them for now. So your professor is definitely one of your best resources, going to know exactly how they want you to do the problem. It's a good default position to believe that your teacher wants you to show your work unless they specifically tell you on a problem that you're supposed to use a calculator, or if it was a problem that was like this one where you didn't have any other way to solve it other than to put those equations in the graphing calculator, because there's no way you were gonna figure that out by hand with variables and the exponents. You don't know how to deal with that in this class. So, all right. See you guys next time for 4C. Bye now.